So good morning everybody. Today today I have completed in this weekly contest 229. Let me check this is working. Okay, this is recording. And I have solved all the question in past 10 minutes. So let me discuss the questions. So the first question is you are given two strings, word 1 and word 2. Word 2, merge the strings by adding letters in alternating order starting with word 1. So this is basic implementation problem. So what we can do it we can place two pointers I and j and iterate over until I is less than word 1 size or j is less than word 2 size. And then first we have to add word 1, then add word 2. If it is said that if there is no word in word 1, then we can add word 2, or there is no word in word 2, we can only add word 1. So this was just simple implementation problem. Let's go to the second problem. So the second problem is minimum number of operations to move all balls to each box. uh, so this is also simply implementation problem. Here it is given a binary string of 1 and zeros, and we have to say that for each valid index I is from 0 to size of the binary string. A number of steps that will be taken to move all the boxes to that current index. So suppose let the binary string is 0 0 and 1. So the number of steps taken to move so the number of steps taken to move all the balls to index 1 is, first it should be moved here, then it moved here, that is 2. For index 2 it is 1, and for index 3 it is 0. So this is also simply implementation problem. So what we are doing is iterating over all the positions, and for every position we are finding the number of minimum steps taken, and that step will be counted if only that box contain ball, that is 1, if the box is 1. Okay, so let's move to the third problem. Maximum score from performing multiplication operation. So this is a DP problem. As you can see, the number of accepted is less. So let me try to explain this, what is happening here. So we are given some integer number array and a multiplier array. At each step we are, so let me write here. So there is integer array, and so let's integer array be 1 3 2. So what is given in the example, let's take that. So this is number array and this is multiplier array. So add, basically we can take either 1 or 3 and multiply with the first index of the multiplier. So let we say we multiply 3 into 3, and then the we are left with only two elements, 1 and 2, and then we can take 1 or 2, that is from the front or from the back, and multiply with 2. Suppose we take 2 and multiply with 2, then we can take, then the last element left is 1, and we can take it and multiply it with 1. So the total sum will be 3 into 3 plus 2 4, that is 9, plus 4 plus 1, that is equal to 14. Is the answer 14? It's 14. So most of you will be thinking that the most optimal way is to choose multiply the number in the multiplier array with the with the nums of I that gives the most maximum, but it's not. So we have to apply DP here. So we can, so greedy method will not work, so we have to apply DP. So we can set the two pointers I and j, and we can set the DP array as multiplier size. As multiplier size is 10 to the 3, so so we can iterate over the multipliers array and increase our I and j according to that. So what we are doing is we are taking whether we can take it from the front, or we can take it from the back, that is nums of I into multiple of index, or nums of j into multiple of index, that is we can take it from the front or from the back, and we are adjusting our pointer according to that I plus 1 or j minus 1, and we are increasing our index at every point, and we are iterating over the multiplier array, and the it as n is greater than equal to 10 over 5, but it will never going to be that far because m is 10 over 3, so minimum will be taken, and I is never going to exceed m. So this is a simple problem, the basic problem. So let's move on to the maximize palindrome length from subsequence. uh, so this is basic. It is also a deeper problem, where it is said that is you are giving two words, and you have to choose non-empty subsequence from word 1 and non-empty subsequence from word 2, and then concatenate it and then check if it is palindrome or not. So we are said that we have to take non-empty subsequence, so we can't only deal with only word 1 or word 2, we have to deal with both of them. So what we can do is as we can just take the word 1 and word 2 as a single string, a, suppose string a, it is word 1 and word 2, and then what we can do is iterate over the positions. So suppose iterate over I from 0 to word 1 dot size, and for each I we can choose some j, 0 to word 2 dot size, and now we are only have to check that it is a valid palindrome or not, and check, I mean not a valid palindrome means it is a valid, what is the longest palindrome is subsequence it can give, and check what the longest so and check what is the longest so the main condition is that first we can only take the I and j value if their end characters are equal. Otherwise we can't take that as a longest palindrome with subsequence. So we have some I, some starting point, and some j, some ending point, and we are checking that what is the longest palindromic subsequence that we can get from this length of string. So the basic condition is base condition, I mean, if I is j return, uh, as it is, because if I is equal to j, return 1, because that is will be single character, and single character is a palindrome. And if it is two character, uh, two adjacent positions, I mean, and if they are equal, return 2. And we have to check that if character I is character j, then we can add 2, because that 2 will be giving a palindrome. And after that we are just contracting our, what we say, that we are contracting our iterator position, that is I, we are increasing it by 1 and j decreasing it by 1, because I and j are equal, so we are adding 2, and we are checking for the another length, that is we are contracting it. And if else else it means that if a of I is not equal to a of j, that is means that the characters are different, then we are checking for, then we are checking for then we are just increasing I by one time, and checking it for it. And then after this we are just decreasing j by 1 and checking for it. Means it's like this, we are, if we are checking for 0 to 5, let's suppose, then we are just checking for it 1 to 5, and for other we are checking it for, what we say, 0 to 4. And this is going to make a recursion tree, and that is why DP is working here. So another step here, it will be like, it will be like this. We are checking for 1 to 5, that is 2 to 5, and let this be here. And for another we are checking for another we are checking for 2 to 5 and decreasing by 1, 1 2 4, and let this be here. For this we are checking for 1 2 4, and for this we are checking for, we are decreasing j by 1, that is 0 to 3. So this is the basic recursion tree that will be occurring. Hope you understand this tutorial, and if not, just comment it below and I will clarify you. Meet you in the next contest. So today I have ranked 114. So it is my best ranking till now, as was able to solve all the questions without any penalty and with some speed, I guess. So meet you in the next video, and if you have not liked the video, please like it and subscribe the channel for more videos like this.